So group 7 isn't, we only extend it in slightly more than we do at GCSE, but we'll be able to explain some of these properties a little bit more. Okay, so what happens, if you can remember back from GCSE, group 7, the halogens going from fluorine, chlorine, bromine and iodine. What happens to the colour? They get darker, yeah. So the colour, as I go down the group, gets darker. So fluorine is like a pale yellow gas. Chlorine is a green gas. Bromine, can you remember, is like an orangey liquid. And iodine is a shiny grey solid, so they get darker as we go down the group. So we can, if you want, you can put pale yellow. Chlorine is like a pale green. Bromine is orange. And iodine is a dark grey colour. So what happens to the volatility? Yeah, absolutely. So volatility, as we go down, it decreases. So my boiling point or my melting point gets higher. So if we say melting and boiling points increase as I go down. We'll change colour. So fluorine, we said, fluorine is a gas. Chlorine is also a gas. Bromine, liquid. And iodine at room temperature is a solid. And finally, because we're going to be able to link these together, as I go down the group, what happens to the size of my atoms? Increases. Yeah. Atoms get larger. Do they exist as atoms in? They're diatomic, aren't they? So we can change this to F2, Cl2, Br2, and I2. They exist as diatomic molecules. So atoms / molecules get larger. As I go down the group. So these two are linked. How are they linked?
Yeah. As the atoms get larger, the Van der Waals forces are increased. So the boiling points increase and the melting boiling points are increased.
That's right. What's the key thing? They're getting bigger, so they have more. What's the key thing for? They have more electrons. So the atoms get bigger. So the reason why the volatility decreases, or my melting and boiling points get higher, is because I've got more electrons. The more electrons I have, the more Van der Waals forces I have, and the more Van der Waals forces I have, the higher the melting and boiling point. So number of electrons is really important, and it's obviously important that they always exist as diatomic molecules as well. So how about electronegativity? What do we reckon that's going to do down the group?
Decrease.
It decreases down the group. So electronegativity decreases down the group. So fluorine, we know, is the most electronegative atom in the periodic table. So why will it decrease down the group? Why? If we just compare, I've got HF compared to HI. Why is electronegativity going to decrease?
Fluorine has the highest effective nuclear charge because it's got more protons for the amount of electrons in its outer shell. It's got the lowest amount of electron shield.
Yeah, I see. I think it's more because the effective nuclear charge is the number of protons minus inner electrons. So it's always the same as you go down because you've always got the same number of inner
Is it
electrons.
more electron shielded?
I thought it's because the size is fluorine is really, really small.
Yeah, you've got, if you think between here, you've only got, if you think of fluorine, you've got 2 electrons. We just did this, so you've got 1, 2, 3, 4, 5, 6, and then you'd have that covalent bond there. If we have a look perhaps at chlorine, so chlorine I've got another shell. If I've got that, the distance between the pair of electrons and the nucleus is much less, so it's going to be more attracted to that nucleus. Here, I see he's got more electrons to get through. The effective nuclear charge is always the same though as you go down, because it's always the number of protons minus number.
So it's the distance between the bonding electrons and the nucleus.
Yeah, that's right. That's what's really important. That's pulling it together. Yeah, but down the group that stays the same.